In this video, we look at the solubility rules for ionic compounds, and we determine which ionic compounds are soluble in water and which ionic compounds are insoluble in water. We saw in an earlier video that ionic compounds that are soluble in water are called electrolytes, and that's because when they dissolve in water, they dissociate into their constituent ions, and those ions become mobile in an electric field and are able to sustain an electric current in solution, hence the term electrolytes. We also saw that ionic compounds that are insoluble in water do not dissolve to produce freely mobile ions, and therefore do not produce electrically conducting solutions, and we call them non-electrolytes. So it begs the question, how can we tell which ionic compounds are soluble in water and which are not? And what is solubility anyway? The solubility of a substance is the maximum amount of solute that can be dissolved in a given amount of solvent, and typically it is measured in units of grams per litre or grams per 100 mils, which is also referred to as percentage. So a 3.5% solution of sodium chloride would have 3.5 grams of sodium chloride dissolved in 100 millilitres of solution. In order to be classed as soluble, a compound must be able to be dissolved in water at greater than 0.1 grams per 100 mils or greater than 0.1% mass per unit volume. This table here shows a list of soluble ionic compounds with some important exceptions. The first thing we can note is the long list of compounds that are soluble in water with no exceptions. So all group 1 metal salts, all lithium salts, all potassium salts, all sodium salts, etc. are all soluble in water, and there are no exceptions. All ammonium salts are soluble in water with no exceptions. The same is true of nitrate salts and acetate salts. All are soluble in water with no exceptions. Most of the halide salts, the salts containing the chloride ion, the bromide ion, or the iodide ion, are soluble in water. There are, however, 3 important exceptions for each: silver, mercury, and lead. So you can see silver chloride, mercury chloride, and lead chloride are important exceptions. They are insoluble in water. They will not dissolve to any appreciable extent. Silver ions in the presence of chloride ions will actually form a solid precipitate. They will not stay dissolved in the presence of each other, and it is the same for mercury ions and chloride ions, and lead ions and chloride ions. And the same exceptions occur for any bromide-containing salts and any iodide-containing salts. Most sulfate salts are also soluble, again the exception being the salts containing the 3 metals noted above, silver, mercury, and lead, as well as 3 additional exceptions, including calcium sulfate, strontium sulfate, and barium sulfate, which are all insoluble in water. One way to remember these 3 additional exceptions is to note that calcium, strontium, and barium are the heavier group 2 metals lying under magnesium in the periodic table. This table here shows a list of insoluble compounds with again some important exceptions. Most carbonate salts, most phosphate salts, and most sulfide salts are insoluble in water, with the exceptions being that we can't break the rules from the previous table. So all group 1 metal carbonates, group 1 metal phosphates, and group 1 metal sulfides can dissolve in water and are therefore soluble. All ammonium salts are also exceptions. So ammonium carbonate, ammonium phosphate, ammonium sulfide are all soluble in water. But all other carbonates, phosphates, and sulfides are insoluble in water. It's a similar story for the hydroxides. Most hydroxides are insoluble, the exceptions being the group 1 metal hydroxides, lithium hydroxide, sodium hydroxide, potassium hydroxide, etc. And the other exception here again being the heavier group 2 metal hydroxides, namely calcium hydroxide, strontium hydroxide, and barium hydroxide. We will see later on that soluble hydroxide salts are very important, as they are the most important source of the hydroxide ion, which is the most common base that can neutralize acids. The final thing to remember about insoluble salts is that a salt is considered insoluble if its solubility is less than 0.1 grams per 100 mils or less than 0.1% mass per unit volume.